So let's talk about the process of simplifying algebraic expressions by collecting like terms, which is essentially a grouping process. Now, I like to always compare like a grouping process, such as one if you were to be given a packet of Skittles, and I gave you that packet of Skittles and I asked you to group them in some kind of way. Well, most people tend to group them by color, but you could also group them by size, by weight, but you're going to use some kind of logic to group them into different groups. The process of simplifying by collecting like terms is very similar, that we're going to group things that are like each other together, specifically terms, and we need a definition of what makes a like term to begin with. Now, we kind of look at two main criteria, but I like to always add a third as well when we're considering whether two terms are like each other. The first criteria is they must contain the same variables. That includes containing no variables, so constants are like terms with other constants. The second criteria is they must contain the same exponents. Now, when I'm looking at that, I'm more looking specifically at the variables. Do the variables themselves have the same exponents? And then the third thing is the order doesn't actually matter, and I'll kind of explain that one when we come across an example of it. So let's look at this first one here, this 2 subtract 3x plus 7x plus 10. You can see here that this contains 4 terms. I could underline them like this just to break down where our terms are. Remembering that a term starts at the start and then it ends at any addition, subtraction, or equal sign. So we can see here we've got four terms here. For these terms, so any of these two terms to be like each other, the first criteria is they must have the same variables. Now you can see here it's only the very first term, all right, and the last term that don't contain a variable. Now, if they don't contain a variable, they contain the same variables, essentially. So we can group them together here. So to group them, we go through a process of adding and subtracting our terms together, or simply just add them together in this case. So 2 plus 10 will equal 12. Let's actually just quickly change that to white. So 2 plus 10 will equal 12. All right, and then we go through to the next term and see whether or not that's like the other term that we've got here. So this negative 3x contains the variable of x. And you can see that the 7x also contains that variable of x. They do have the same exponent in this situation, in that the exponent is 1, we just don't write that down. So what we do here is we add these two together again. So we're starting at negative 3, and we've got to be careful with our negatives here. So we're starting at negative 3 and we need to add 7. So think of our number line. That'll bring us to positive 7. Positive 4. And then x, like that. And what we've done is we've grouped our x terms together, which I've underlined here in blue. And I've grouped our constants together, which I've underlined here in orange. So let's have a look at another example that has a bit of a difference in terms of the number of variables that we've got. So here we've got the variables a and b. And you can see our very first term contains both the variable a and the variable b. Now, for terms to be like each other, they have to contain the same variables. So our second term only has a, so that's not the same. Our third term only has b. However, our fourth term does contain an a and a b. However, it's in the other order. Now, if you remember my third point, the order that they contain those variables doesn't matter when we're considering whether they're like terms. So the a and the b, or the b and the a, we say that they are the same, they are similar, so we can combine them together by adding them with each other. So we've got 2ab, add 3ab, or ba. So we want to add those coefficients, the 2 and the 3 together, which will give us 5ab. And then what we want to do is we want to move on to the next term, this negative 3a. And what you'll notice is the other term that we've got contains a b, doesn't contain the same variables. So we can only group the negative 3a with itself. It's as simple as it goes. And then our final term, this b term, once again, doesn't have anything else that we can group it with. So this will just be plus b at the end. And that's how we simplify an expression that has multiple variables. So now let's have a look at an example where we've got powers that are different with each other. So far we've always had the same power. So we've got the one variable in this example, that variable is y, and all three terms do contain the variable of y. However, our first and third term contain the variable y squared, and you've got to remember that they have to contain the same exponents as each other to be like terms as well. So we can combine the y squareds together, but we can't combine that negative 7y with these. So how do we combine them? We add them together. So 12 plus 10 will be 22. So this will be 22y squared. And then the last term, well, we can't simplify that any further. So that's just subtract 7y. And we've now simplified this by collecting our like terms. Let's have a look at one last example. And that's the example 3x plus 5 plus 8x minus x. You can see here that we only have the one variable here, and that's the variable of x. And the first term contains that variable of x, but so does the third term, and so does the fourth term. So what we can do here is, and this is important to know, is we can add them all together. So we can add the 3x, the plus 8x, and the subtract x all together. Now what's important when we do this is we've got to realize or recognize the coefficient of the negative x over the right here is negative 1. So we're going to be subtracting 1 at the end. So we start with 3, we add 8, which is going to be 11x. Then we subtract 1x, which will be 11 subtract 1 is 10. So we've got 10 x's. And then we're left with just the coefficient, the 5 that's on its own, the constant. So we can't simplify that any further. So we're just going to be left with the plus 5. So when we're simplifying like terms, we're just going to remember that we've got to identify whether or not two or more terms are like each other. And if they are, we simplify it by adding the coefficients together.